Alrighty, so for today's lesson, we're going to talk about tangents and secants. And there are three possibilities when talking about the intersection of a circle and a line. In A, you see that the circle and the line have no points of intersection. If you look at B, you can see that the circle and the line have 1 point of intersection. And then you can see that in C, the circle and the line have 2 points of intersection. So when we talk about a tangent is a line that intersects the circle in exactly 1 point. Okay, so it's going to tangent just going to touch the line. It's going to be intersecting exactly 1 point. That point of intersection happens to be called the point of tangency. At any given point on a circle, only one line can be drawn that is tangent to that circle. Okay, so there's the example that we're showing you down here. Through point P, only one line can be drawn through it that's tangent to circle O. When we talk about secants, secants are or is a line that intersects a circle at 2 points. So what you see here is that line AB goes through circle O at 2 points, A and B. So there's a theorem that talks about if you've got a line that's tangent to a circle, something happens when you have a radius that's drawn to the point of tangency. So when I draw this radius OP to my tangent line M, something happens with OP and line M. And here's where we're going to look at a sketch pad. So take a look and you can see that when you have this tangent DC drawn to, or radius AB drawn to that, notice how the angles on either side are right. As long as you can manipulate this thing, if I can do it from here, I don't know. Let's see. Let me go. Can I turn this thing? All right, well, I can. Let me just pause this for 1 second and go to my computer. Okay, so I can actually move this tangent line around my circle, and it doesn't matter how it gets moved. There's no way that anytime you've got a radius that's drawn to a tangent line at the point of tangency, you always have these 90-degree angles, okay? So what that means here is we can say that for sure, let me go back to the smartboard, is that a line that is tangent to a circle is perpendicular to the radius drawn to the point of tangency. So line segment OP is always going to be perpendicular to, in this case, line M. Okay. Then we talk about things that are called common tangents. And a common tangent is a line that is tangent to each of 2 circles. Common tangents can be either internal or external. If you look at the common internal tangent, it's a line that intersects. The common internal tangent intersects the line segment and joins the centers of the circle. So what happens, I've got 2 circles that have these 2 centers that connect a line segment with them. The internal tangent is the line that actually goes through or intersects the segment that connects the 2 centers. If you are an external tangent, then when you draw that line of tangent line to both circles, it does not intersect the line segment connecting the 2 centers. That's the difference between internals and externals. The diagrams below illustrate how circles can have 0, 1, 2, 3, or 4 common tangents. Okay, so no tangents for these 2 circles here. These 2 circles that are touching, there's 1 common tangent. When these 2 circles overlap, there's 2 common tangents. By the way, this is an external tangent. This is an external tangent. Here, when there's 3 common tangents, 2 are external, 1 is internal. And when there's 4 common tangents, 2 are external and 2 are internal. Other things about circles, relationships of circles in the same plane. If the circles never touch, we tend to call them disjoint circles. If the circles share the same center, they are called concentric circles. Tangent circles, there are circles that are internally tangent because one circle's inside the other, and there's circles that are externally tangent, one circle's outside and they just touch in one place. And this is kind of like a Venn diagram initial, or sort of. These are when you've got two circles that are intersecting. Okay. Then we're talking about two tangents that are drawn to a circle from the same external point. And it turns out that they happen to be congruent. So I was going to show you this on the sketch pad, which I will. But as long as there's a point outside the circle, if you want to connect the external point outside the circle to a point on the circle, you're going to have congruent segments. So we can look at this sketch pad real fast. So what happens here is I've got from point B, my external point, you now happen to have from B to A is a tangent and from B to C is a tangent. And I can draw, I probably have to go to my computer for this. But I can move that external point around. And you'll notice that the length of those two segments, maybe not that way, let's see. Not that way. What do I want to do here? There we go. So as I start moving these points around the circle, the points of tangency, my line segments still remain the same. So I start moving things out. If I start maybe moving this thing, make it bigger. So as long as you're coming from one point on the outside of the circle, it doesn't work that way. One point on the outside of the circle and your tangent lines, then those tangent lines have to be congruent. Okay? Let's get out of this one. So AP and BP are congruent. So here's another one that you have. If you've got two tangents that are drawn to a circle from an external point, then the line that passes through the point and the center of the circle is going to actually bisect the angles formed by the tangents. Okay, so let me just put this in here and I'll show you on the sketch pad. So what happens in here is we're going to pass through the center of the circle, and then over here we're going to bisect the angles formed by the tangents. So let's take a look at this thing real fast. If I were to take these tangent segments, whoopsie. So what's happening here, and I need to go back just a second. If two tangents are drawn to a circle from an external point, then a line passing through that point in the center of the circle bisect the angles formed by the tangents. So we know that the radii drawn to the point of tangency are right. We've got that already. And then what happens is take a look at the tangents that are congruent, right? So from B to A and from B to C are congruent. But look at this angle CDB. So from CDB, it's the angle right in here, and then ADB, so the angles that are formed by the center and that line segment BD, as well as ABD and CBD, the angles that are formed over here, okay? They are congruent. So as I start moving around this thing, my tangents still remain congruent, and then the angles that are formed by the tangent and the center point remain congruent, and then you can't really see that because it's kind of off the screen. And then with B, that guy out here, whoopsie, remains, I don't know where this little point come from. Then the angles out here, ABD and CBD, remain the same. Okay, so that's just another thing that we're talking about here. If, again, you've got a line segment that connects the tangent, the outside exterior point to the center, then the angles formed from the outside point through the center and the point of tangency, outside point through the center and the point of tangency, those will always be congruent. Similarly, if you want to do the angles that are by the exterior point, so you go point of tangency, exterior, center, point of tangency, exterior, center, those guys will always be the same. Okay, let's go back here. No. So then the angles created by this line and the two radii is the angles formed. This is going to be congruent too. I got to fix some of the wordings here. This is going to be congruent. Is going to be congruent also. So let me just do some stuff over here. Okay, so what happens is if you connect the two radii, if you draw on your two radii, which we know happen to be, I'm not oriented very well, which happen to be right angles, right? This is a right angle, this is a right angle. If you now connect the center to that point on the outside, the exterior point, these two angles here are congruent, and similarly, these two angles in here are congruent, because these triangles happen to be congruent. So really by CP, CTC, all this stuff happens. Okay, so let's then go to the next slide. And that's it. That's the homework. Okay, so you should be good to go on the homework.